this is my capstone project, and the idea of this project is to find suitable offer products from REWE and ALDI. Right now I'm just using REWE and ALDI, but the future idea is to use more stores. The main goal of this video is to just showcase how to use this application and how this application works. On the left side we have two input features. One is postal code and the other one is model selection. In postal code, by default we see all. This indicates that we get all the offers from all the stores of REWE and ALDI, but we can also be more specific by giving postal code so that we get nearby offers. In model selection, BERT is a baseline model, which is a smaller model, and it is really good for semantic searches. And I've used an open source model, which is Qwen3, and I've downloaded a 4 billion parameter model from Olama. And the third model, which is Gemini, which is a larger LLM model, and it is very bigger and better when compared to other model. And I wanted to have 3 different versions just to evaluate the performance of response. So let's start by trying an example. I've provided the postal code of my location, which is near to Ha away. And let's ask me, I want to buy some fruits. And oranges. And I can find these products here. Found bananas, oranges and apples, so that's why I want to see whether I retrieve them. And Gemini, I use Gemini API, and right now it does not do any scrapping because I already have this postal code address data stored in my vector store, so it directly directly fetches data from database and performs RAG. And we see that we retrieved banana, apple and oranges, and we can also view them and see if they are right, and we get this data from metadata when we perform RAG. Yeah, so we got right products. And to see some technical stuff in the console, what exactly happens is when a user asks a query like I want to buy some fruits like banana, apple and oranges, then I first use a query generator which generates a query of banana, apple and oranges. So it creates a list of products from the query and then perform a loop RAG of each product for banana and retrieve similar products, and apple and retrieve similar products, same with orange. Once I get the product data, right now we can only see the product name, but actually we get the metadata and that will be passed to other LLM, and that LLM have to decide based on the query, and those rules and instructions are given in the prompt, and we get a JSON response with the metadata, and this will be passed to the UI, and that's what we see here in a nice tabular structured way. Now I'll test the same question with BERT and see how it performs and what kind of products it retrieves. And it retrieved mango and true fruit smoothie. I think it is not a very bad results because it's somewhat related to fruits. And this is not a fruit, but it's a fruit shake. Yes, yeah. Okay. Now I did not test with Qwen because Qwen is taking bit time for performing RAG and using LLMs because it is running locally and it takes more than 4 minutes, and I want to skip for this demo. Now now the plan is to use a code which is not there in our database so that it performs scraping. Let's see, somewhere in south near Munich. select Munich, see REWE, and see the store 80686. Now let's say I want vegetables, potatoes and mushrooms. Now as I said, this location might not be in the database, that's why it's performing scraping. And once it scrapes, first it scrapes from REWE, then it scrapes from ALDI, and after scraping it stores in the database. Right now we already have data of 51 locations, and we see less products because most of the stores have common products, and I'm just deleting duplicates and just entering the unique products into the vector stores. And we can also see the logs in the console. Once all the scraping is done, we perform ingestion, so the data is entered into Gemini table by using Gemini embedding model, as well with BERT and Quen. That's why you see 3 tables in the 3 documents in the quadrant database, and after that it performs RAG, and RAG it first sees the query. Then right now we are using BERT because we are not using any query generator, so it directly searches similar product based on the query. Let's ask the same question for Gemini and see whether we get better results, because I think these are not the results which I'm expecting, because it's completely unrelated, because we did not directly ask the products for BERT. But in case of Gemini, it could identify correctly because it understands what products exactly we are asking, and it searches for those products from the vector database. But BERT really performs well when we ask direct product, like I say I want raw chicken breast. Maybe it searches for chicken and it retrieves the similar products. And if I also go and see, my pin code gets updated with this pin code, and next time when I use a similar pin code, I don't get any issues. Yeah, let me off this and try again, so that 80686. It might take because it have to load the embedding model. 0668. Yeah. I'm performing BERT because it is bit fast as it is small and running locally. Yeah. When I said ice cream, it retrieved ice tree. But I think I took a bit long time than expected, but this is what I want to show. Yeah, I have provided more details in the GitHub and in the report. Yeah, thanks.